Hello, guys. Welcome to yes. Hello, guys. Welcome to day three of the machine learning bootcamp recap. Today we are walking you through. Today I'll be walking you through the end-to-end machine learning project, TrendCaster. So let's quickly go to the demo and see what we are looking at before we go through the slides. Yes. So this is the bootcamp website where the students access the resources for every day. Okay, so this is the live demo of TrendCaster. Let's see what it looks like. So TrendCaster is like imagine like in a world where everybody wants to where the social media world is now like obviously a thing. So Trendcaster is like a device that a machine learning model that was built based on the fact that it's trying to predict whether a video is going to trend or not. So it has four target groups, four target labels, which is rising, declining, stable, and seasonal. So let me walk you through how the demo works. So these are 9 feeds. Keep in mind, I mentioned 9 feeds. So the platform, let's pick a platform. So the platform is where the video is posted, whether TikTok or YouTube. Let's pick YouTube. Content category. Uh, um, I remember the kids they mentioned sport. Yeah, and then audience, where the audience is based. They mentioned Europe, language. We are picking English. Uh, so creator tier, that is based on the word of influencing, whether the creator is micro, means that the average number of views they have, is mid, is like they have average views, and then when we say star, it shows like how popular the creator is. There are different tiers of creators and people that are like they post just one content and then it blows up and the like. So let's pick macro. Okay, so traffic source, they screamed hashtag, and so it's like a word now that everybody wants hashtag. They put hashtag on their videos, put hashtags on whatever it is that they are doing. And then the device brand, yes, they screamed Apple. And how long the title character length is. So the title character length of the video. So let's pick 10. Yeah. And then posted on a weekend with a proper hashtag. So this is like the strongest signal in the model. So we'll take that as a yes. So let's predict the trajectory and see. Okay, so the result prediction and confidence appears here. So that's it's telling us that the video is rising. The confidence is 88.6%, which is actually really good. And these are all the class probabilities. So that's that about trendcaster. Now back to our slides. So yes, the model that performed the most that you are seeing on the website is an XGBoost model. Yeah, the classes like I mentioned earlier, rising, stable, declining, and seasonal. So yes, that's the problem statement is a creator is about to post a video. Will it rise, hold, steady, decline, or spike seasonally? So Trendcaster predicts the trajectory. The methodology that we used for the model is a CRISP DM methodology, cross industry standard processing for data mining. So it starts with business understanding to data understanding to data preparation to data modeling to evaluation and deployment. Yes, so yeah, I just showed you the demo. I showed you the 9 fields category. I predicted the trajectory and then read you the output. Uh, So the four classes. So when it is rising, it means that it is gaining traction. Views are growing over time. The video is finding audience. When it is stable, it means like nothing is going on. And in the target class, the stable is the most common class, and then declining is losing momentum after an initial peak. Traffic is cooling off, and seasonal is tied to a recurring event, just like how videos of football related content was probably the bomb at this previous in the past few months, based on the World Cup that was going on and the season that we had. So yeah, so how good is it? Honestly, the test accuracy was 57.1%, and the baseline to beat was 55.4%. Write that down and know that, thought. The macro F1 is 0.455. So F1 is like the average of precision and recall. Like I mentioned earlier in the previous video, that precision is the false positives, like and then recall is the true positives. I'll get to more explanation of F1 score and precision and recall once I walk you through the back end of how the project came about. The training time for the XG Boost was 8.1 seconds. No surprises there. XG Boost is a really, really fast model. Imagine the number of rows that he had to analyze. I'll probably still be on this project till now, because imagine analyzing 88,628 rows. So the weekend hashtag, like I mentioned earlier, drives 27% of the model decision making, and the declining class, that's the weakest spot. And that's a data limitation that we are going to talk about too. And then these are some of the engagement features that were excluded. But since I'm here now, I'll walk you through the end-to-end project. Oh, yes. One more thing before we go. The three models, yes. So these are the models these are the leaky features that we excluded from the model. These are like we'll call them answers to the questions, because there are some things that a content creator is not aware of before posting the video. You won't know the like rate, you won't know the share rate, you won't know the comment rate, you won't know the views per day. These are features that were in the data set that we had to exclude. And these are the clean features, the things that the content creator would know beforehand before posting the videos: the platform, the region, the category, the creator tier, the traffic source, device brand, etc. So three models, one winner. Yes, we have three models. The one with the highest accuracy was 63.7%, which is the logistic regression. I know at the back of your mind you're like, why are you not picking logistic regression? You are going to find out. Random forest, who had 50.3%. Remember I mentioned something about the baseline, which is like the benchmark for the model to beat, which was 50.3%. And then XG Boost, which was 57.1%. That was why we picked the XG Boost. So yeah, you can go here and try it live and play with it as much as possible. Aha. So this is how you can deploy this. I'll show you this at the when I take you to the end-to-end project. When I take you to the back end of the project. So let's go to the back end of our project and see how we arrived where we are. Yes. So this is TrendCaster. This is the back end of the project. Yesterday in the videos for day two, where we were writing the codes, we did not really use markdowns because of our time. But the standard practices of writing codes is very important to use markdown, so that whoever it is looking at your code is can actually understand what it is they are looking at, and you are not and then if you are not there, your your colleagues at work or your colleagues that you're working on a project together, they can exactly understand your thoughts. And so it's very important to use markdowns when writing your codes. So business understanding, what is the goal of the project? The goal of the project is to work on your mind and make you see the possible use cases of machine learning in your everyday life. You have it in your pocket, you have it everywhere you go, you have it in your emails. One of the example of the machine learning you have in your emails is the naive base, where it's sorting your emails and whether it is spam or not. So at the end of this session, I'm sure the machine will tell us what makes a post go viral and the things that makes the machine makes the decision. So the data understanding, the data we sourced for this project is cargo. To make our lives easier, it was a prepared data set and with few cleaning. So remember, like the standard practice that I mentioned yesterday, is to import the libraries that you need. Import pandas as PD, import numpy as NP, Seaborn for visualizations too, and matplotlib. So there's something interesting that I told the kids about matplotlib. Earlier, before machine learning became a thing with Python, matplotlib um was used for machine learning then. Can you imagine? You can fact check that if you can, if you doubt it, you can fact check it, and if it's wrong, I'm happy and open to learn too. DF, we called our data frame DF this time. In the previous video we called it penguin. So DF equals to PD dot read underscore CSV. I used a Dropbox. I like to use Dropbox for my project. I would have liked to show you how it works, but because of our time, I use Dropbox. I copy the link in the Dropbox and then I change the backend here from it's always DL equals to 0. You just change it to raw equals to 1, and then from there you move on. So the df.ed, you can see that we have 32 columns and 32 columns. df.red.ed, if you remember what I told you, that it loads the first 5 rows by default. So this is our columns, 32 columns. And df.info, we can see that we have 50,000 entries, 32 columns, and 50,000 rows. So which it means that our data set is really big. And non-null, it means that the number of missing values in our data set, and we can see that there are no missing values in the data set. We can see that we have a float, like I mentioned yesterday, that floats are numbers with decimals. Integers, we know integers are whole numbers, and objects are like variables or strings of things that are contained in the data set. So what does this tell us? Yes, exactly what I just mentioned. Objects are a distinct entity in memory that contains the data. So df.describe is like trying to see the measurement of frequency, the mean, the standard deviation, the minimum, the 25th percentile, and the maximum. So we see the frequency of distribution for the numeric values in that data set. So yes, is null. We can see that like I mentioned from the df.info, no missingness in our data set. So exploratory analysis. I mentioned something really important here, that when you're working on a data, you need to really explore your data. There are always interesting things for you to see in your data. This is where exploratory analysis comes in. And then I made reference to Dora the Explorer, that Dora the Explorer was always curious, that when you're working with your data set, you need to be curious. You need to like explore your data set so you can get the full picture of what you're working on. And then getting a full picture is going to help you is going to help you is going to help you and then understand your data set. Something that came to my mind just now was that in the TrendCaster video, in the usage of TrendCaster, the kids make some they made some reference about how we can improve this project. You too, I would like you to think about how you can improve it. Some of the things that they mentioned was that it would be nice if Trendcaster could recommend hashtags. It could be nice if it could suggest possible content that could be made. They mentioned that it could be nice if the trajectory, if once you click on predict, um, it pops up directly, not that you have to scroll back up. They mentioned a lot of use cases that on how they can improve it, and I want you to think about that too. So back to our exploratory analysis. So yes, what I like to do I like to explore my data a lot because I don't like being blindsided. If I don't explore if I don't explore my data, how would I understand what exactly it is that I'm working on? So the target label, we can see that the stable class has 27,000, which is the highest. The rising is 12,000, the declining class. We visualize this because it's really important to visualize. Is When you're exploring data, visualization is the best way for you to look into it. Point in case, growing up as kids, we can remember almost all the pictures from comics and the likes that we read. So that's let you understand that visualization is really important. It's the basis for how things stick. You remember a lot of things that you see compared to things that you hear. So visualization would let you explore the data. We can see, if you notice something here, you are seeing a number that I've mentioned earlier. I mentioned a number earlier about the baseline to beat. So the baseline is the 55.4%. And I'm sure you are thinking about why. Why is because the baseline is 55.4%. That's the percentage of the target label of the stable class. So that's why we picked it as the baseline to beat, because more than half of our videos are stable. They are not going viral. They are not dying. So if our model just flip the coin and gets 50-50, it would already be right 55% of the time. So if we need to pick a model, it has to be more than 55%. This is a question for you to think about. If stable is the most common label, is that good news or bad news for our model? If yes, so based on your answer, why? Ask yourself why. So let's look at the trend by platform. Yes, this is the trend by platform. Yes, the trend by platform. We could see that TikTok and YouTube Short have uh, different trend by platforms. And then when the students were observing this data, they mentioned something really interesting. They said that a lot of rising videos were on TikTok. And then he mentioned that does that really mean that maybe the TikTok were having a lot of traffic compared to YouTube? And I answered that I'm unsure about that because I don't have access to TikTok and YouTube numbers, so I can't just deduce and guess. If you're going to make decisions, you need to make decisions based on data, not on intuition. TikTok and YouTube behave like different words in this data set. And then to the trend by category, you can see in my table of contents that the standard naming, I'm following the standard naming convention, so that whatever it is I'm working on right now, I'm at trend by content. And you can see that everything is step by step. So it is very important to write your codes step by step. Write readable codes, really important. Even if you are vibe coding, you need to write readable codes. So trend by category, we can see here the trend by category, the cross tab, which videos are most likely to be rising. And the kids mentioned that sports and gaming, they are always rising. And then I asked them that what sector surprised them the most. And then they mentioned that yes, what sector surprises you the most? And then they mentioned about the education. And I asked them a question that if education video are not rising, what does that mean? And then we had a discussion about brain rot, where people are not paying much attention to videos that could educate them. What could be the reason for that? And then we had like a back and forth discussion for like 2 minutes, which was really, really amazing and insightful. I'm genuinely proud of them. So the leakage demo. Remember, we had 32. We have 32 to 33 columns, if I'm right. So we need to trim our data set. And in the TrendCaster, we had only 9 categories. You can see only 9 fields here. So here we are, the leakage demo. We need to remove leakages. Why we can't use engagement metrics, the leakage problem. So these are likes per day, relative like rate, log, views per day. It is impossible for someone that is trying to post a video not have all those figures yet. So if we include these videos, if you include these features into our videos, into our model, it means that the model is cheating. It's just like you are writing an exam and you already know the answers. You have been given the answer, so you are not even really doing anything. You get 99.9%. But when you are now put out there into the world to get it done, you don't really understand what it is that you are doing, because you cheated your way, and you cheated during the exams, and now you can't defend what you're doing. So it's applicable to the model. We need to remove these leaky features. They are leaky because they will feed into the data, into the model, and the model would not learn anything. It will just be relying on these answers to make decisions. So these are leaky features that we had to remove. These things are called data leakage. So features that could cause data leakage, we removed them. So we threw them out. So that is why we threw out the engagement features. So yes, so another thing is another thing that you could think about is, can you think of another situation where the best clue is actually cheating? Think about, yeah, predicting exam grades. What information would be unfair to use? Yes. So another thing that we did here is also to check correlation. And yes, this is the data preparation step. Yeah, this is still the data understanding, and this is where we remove the data leakage, the things that I mentioned earlier about leakage. So now we picked 9 features from 32 columns based on 3 rules: no leakage, no redundancy, and they are interpretable. So these are the features that we picked. So text richness. I think I eventually dropped this because I did not understand what it fully meant. So I think I dropped this too. So yes, feature filtering. This is where we remove the leaky features. Yes, and now down to data preparation. Someone say data preparation. So data preparation is the third step in the methodology that we used. So I did something here called correlation, the correlation matrix, because we have 9 figures, 9 features left. We need to know if they relate to each other. So this diagonal, this is completely normal. But if we had they are completely normal, because platform relates to platform, region relates to region, language to language, category to category, creator tier to creator tier, traffic source to traffic source, device brand to device brand. But you can see that we have a good correlation in we have the correlation matrix is actually looking good, because because the correlation matrix is actually looking good, because these features are not related to each other. So we now had a discussion about correlation and causation. Imagine it's raining, and because it's raining, does it mean that imagine someone is wearing an umbrella, is holding an umbrella, and they have a jacket on, and a rain jacket on. Does that mean that because they are holding an umbrella and they have a rain jacket on, it's going to rain? I don't know if you understand what I'm saying. We had a discussion about causation, correlation, and causation. So, like for example, I used the analogy of a jacket. So now imagine that you notice that I'm always wearing a jacket and it's cold outside. You might say there is correlation between wearing a jacket and cold. But would it be correct to say like wearing a jacket causes the weather to be cold? So that is a trap that data can lead you to, because most of the time you'd realize that correlation is not equal to causation. Because two things occur together does not mean that one cause the other, does not mean that they are totally related events. They could be separate. So correlation is not always causation. So it's something to put in mind. And then we encoded our categorical variables. Why? Why did we encode our categorical variables? We needed to encode our categorical variables because the model we were employing here does not work with strings. So we had to convert it to numbers. And then when we were converting it to numbers, we used one-hot encoding. Encoding our categorical variables, we used label encoder to encode it. So we changed it to ones, to zeros, to ones, to zeros, to ones, to zeros, because that is how the model understands. The model does not all models are good with categorical variables. So to avoid that, we had to encode our we had to encode our data. So target label encoding, we encoded our target label encoding. This is like the target label encoding is like making declining class 0, the rising class 1, the seasonal class 2, the stable class 3. You can see here in the code. And this was the shape before encoding. This was the shape after encoding. The next cell is going to show us what the encoding looks like now. You can see it's saying true, false, that is one zeros, one zeros. We have like and they are all in booleans now. Most of them are in booleans. We have 48 now. So we encoded our data so that the model can really understand it. You can try you can try and understand it yourself. You can and when I talked about it, I think the children, the kids, they mentioned something about one math feature, something, and then I asked if it was related to Abascus, and then we had a stalemate about that. So yeah, so one not binary code feature, something. I've forgotten what they called it, but I promise to look it up and get back to you. So we convert any boolean columns into integers. So the boolean columns, we converted them to integers. So now we have 51 and our model is fully encoded now. So yes, moving to the train test split. It was explained yesterday about the train test split, that the train test split is you train 80% and then you test with 20. Why do you train 80% and test with 20? You train 80% and test with 20 because you cannot train your model with 100% of your data. If you train your model with 100% of your data, then there is no way to test if the model is actually working. There is 70-30, there is 80-20, there is 90-10 split. But the standard practice I would encourage to use is the 80-20 split. So why we split, we used a method called smooth. Do you know why we used smooth? We used smooth after splitting our data set. So this is our training. So our training set has 40,000 rows. The test has 10,000 rows with the same number of features. So we apply smooth to the training set. Why do we apply smooth to the training set? We can note we noticed when we were checking. That's why data exploration is good. While we were exploring our data set, we realized something, that the baseline, that the data was skewed towards one side, towards the stable features. We had 55% stable and only 9%. So if we train directly on this, the model will be biased towards stable, always biased towards stable, biased towards stable. So smooth, which is called the synthetic minority over sampling technique, it creates it creates synthetic examples of the rare cases and makes the data balance. So I gave them an analogy that smooth is like when you use sandpaper to smooth rough edges. Like I explained to them that if a carpenter is working and they need to work on a wood to make it smooth and balanced, they use their tool to grave it, to make the grain and shape it out and to make it smooth. I said that's exactly the kind of work that smooth does too for our data. We can see here that this is the training set before encoding. We can see how biased this is, and then this is the training set after smooth. So now everything is balanced as all things should be. So with it being balanced now, you imagine you are trying to recognize 4 fruits, but you've only seen apples and a couple of mangoes. You'd be able to, every fruit that you see, you just say, oh, that's an apple, that's an apple. And then when you see mango, you still say that's an apple too. So smooth is like it gives us fake realistic mango photos. So we have equal practices of each type. The model becomes balanced, not because the word is balanced, but we are balancing it in training. So and then to the next stage, which is the data modeling and evaluation. I know earlier I asked you to pick between 3 of the models, which was the logistic regression, the random forest, and the XGBoost. So you saw that the logistic regression performed well. The evaluation period is going to, the model evaluation is going to show us what happened, why we picked XGBoost. So this is our model evaluation phase. You can see that we are almost done. Yeah, so this is the model evaluation phase. We can see that the model, the logistic regression, it performed really well. It was really good. 63.7%. Wow, fantastic. But looking at the classification report, you can see that this model is lazy. Why did I say it's lazy? You can see that the precision for declining class is 0.00, the rising class is 0.52. It got predictions for rising, seasonal, and stable, but the model was lazy because it did not predict anything out of the declining class. So what use is that model in the real case? In a real case scenario where a model is declining, so the model will purposely ignore the other classes and only focus on the 3 questions that you are good at. So because you are good at mathematics, English, and biology, you refuse to focus on other subjects. So that's exactly what the model did. It's not focusing on the declining class. And then looking at the confusion matrix, we can also see that it did not predict the declining class at all. So what use is that model? It did not predict the declining class at all. No prediction was done. So that does that make it a good model? No. So that's why we crossed out the logistic regression from our model. So trying a stronger model, we picked the random forest to see if it's going to do better. And then the random forest too, it's this is the random forest test accuracy. Logistic regression was 53 for 63%. The random forest did better predicting each class, but it did not beat the baseline. You can see that the declining class, the rising class, the the seasonal, and the stable, the random forest was able to predict this. It had an accuracy of 50%. So that's even less than the baseline, but it did not do justice to predicting all the classes. it did not do justice to predict all the classes well, but it was considerably better than the the logistic regression. That's why it is very important for you that when you are evaluating your models, that you don't just only evaluate on accuracy. You need accuracy, you need precision, you need you can use accuracy, you can use precision, you can use recall, you can use F1 score, you can use relative object characteristics area under the curve, ROC, AUC curve. You can use the confusion matrix too. But the purpose of this learning, we are using just accuracy, confusion matrix, precision, recall, and F1 score, which I would explain as we go on. So these are the feature importance. The feature importance is really good when you are working on your model, so you don't make the mistake of making assumptions about what it is that led to the model predicting what it does. Like in healthcare, it's very important for, if you are deploying a model as a support system for health workers to use as a supporting system, they need to know what is making the models to make decision. You can't just say, oh, this is the numbers from the models and they will run with it. No, they call it black box. So because to avoid to stop labeling this model black boxes, we look at the feature importance. Sometimes we use sharp, sometimes we use sharp, which is like a form of explainable AI. Sometimes we use lime too, which is like a form of explainable AI. You can look that up and brush your knowledge on it. So model tuning and comparison. So we used we trained the XG boost, and now with the XG boost, you would see why we picked the XG boost. It had a 57.1% accuracy, which was better than the baseline, and it predicted the class is better all rounder compared to the other class, compared to the logistic regression, compared to the random forest. Yes, it faltered in the seasonal, but it was better in form of accuracy than the baseline. So this is also the feature importance. You can see a similarity here, the weekend hashtag boost. So we trained 3 classifiers on the same smooth resample training set. The XZ boost wins. The logistic regression looked impressive at 63.7% accuracy, but it gained the imbalanced test set. The random forest tries harder but loses overall accuracy. XGBoost finds the sweet spot. It has the highest macro. It has the highest macro. It has the highest macro score, and then it was also fast to train. So what this tells us, the hard truth, yes. So these are the Yes, so these are some of the things that we also noticed in our feature importance. Uh, we could see that what it represents, the category lifestyle. I'm trying to run through this quickly. You can see something really interesting, the content in Korean. So it means the language Keho, the Korean language too, is facilitates how the model predicts whether a video is going to trend or not. So the hard truth about the declining class. The models struggle with the decline. The models, all 3 models struggles with the declining class. The best F1 score we achieved was 0.162. This isn't a failure. This is not a model failure. It's a data limitation from our data set. The features that would predict whether a video is declining are exactly the ones that we excluded for leakage. If we added this, that would have derailed the whole project and the model would perform better, but it's not learning anything. So that is why we picked that. And back to our confusion, back to our confusion matrix. So this is the model. This is the accuracy 63.7. The for logistic regression, once again, model for the accuracy for random forest 50.3 and XGBoost 57. These are the macro F1 scores. So the precision class, like I explained in day 2, is like how many of it what did our model get correctly. That's precision. How many of the positive did the model get correctly? But with recall, it means that how many out of all the predictions that the model made, how many were actually positive that the model did get correctly? So, but to now balance the two together, we now used the F1 score. The F1 score is the average of both precision plus recall. Do you understand? So that's what the F1 score means. And now let's go to the final stage, which is deployment. So deployment, I deployed this. There are different ways where you can deploy your best model. I like to deploy my models using GitHub or Hugging Face. Like for TrendCaster, I deployed it using Hugging Faces. So I just download the model. I download the model, and when I download the model, you can see there's on the last part here. I download the model, and once I download the model, I take it to GitHub or or to to Hugging Faces, and then I put an app.py file there. I put the requirement file, and then I run it and it deploys. But for the sake of this project, we are using Gradio. We are using Gradio because it's easier to do. Bear in mind that when you are installing Gradio, once you are done with pip install Gradio, you comment out the section. If you don't comment it out, when you run all the cells again, it will reinstall Gradio before it runs again. Because I noticed during the pitch of the students, they had a few issues. Their model stopped work, their live demo stopped working. That, and one of the major reasons is because they ran all the cells again instead of them to start from just the deployment phase after just to show the demo. You comment out the pip install. Once you comment it out, it will be easy for the model to run quickly, for the cells to run quickly, and then deploy the demo. So you import Gradio as gr, and then you deploy it using these codes. The codes is relative. You can just blend in the codes. You can use cloud to generate the code for deployment, which will be shown to you in day 4 of this series. So you can use Gradio to deploy it, and when it is done, it's going to give you a website that will temporarily last you for you to show your demo. You can see it's a bit identical to what we have with TrendCaster here. So this is, let's try and use it again. Let's do Africa, let's do Europe. Yeah, so it's something also that we could correct about the language. In the data preparation, we did not clean the language. We could have made it better, but I did it at the back end of my app.py when I was deploying on Hugging Faces. So ENDE, these are just short forms of the languages, but it's not good practice for people using your app to be guessing what each section means. So compared to TrendCaster here, where we fix that, where you can see that English, all the languages you'd understand just by looking at it. So let's pick EN, which should mean English. Let's pick a different category. Let's pick gaming. Uh, let's pick mid. The traffic source. Let's pick let's pick um let's pick search. The brand, let's pick Google. The title length, let's add the weekend hashtag, and let's submit and see. So he's saying it's a seasonal video and the confidence of the model is 71.9%. So this is how you can deploy your live demo. This is the link to use on a public URL. Control C, Control V, and then C. Yeah. So this is the live demo using Gradio. So some one thing that I would like you to think about is when it comes to accuracy as a metrics. Yeah, this is an assignment for you to think about when it comes to, yes, so when it comes to accuracy as a metrics. Why did the highest scoring model lose? TrendCaster tested three models: logistic regression 63.7% accuracy, XGBoost scored only 57.1%, and yet XGBoost was chosen and logistic regression was unusable. Explain why the highest scoring model lost and what this teaches us about the sentence, my model is 90% accurate. So I want you to go and think about that. You can, yes, and yes, you can email your response here. Um, the student, they participated really really well in that aspect, and we had like a really nice time discussing about the take home assignment. Yes, so they wrote an essay of like 200 to 2 of to 300 words. So you can do the same too, or you can just have a discussion with your friends or pal after watching this video. So that's that about running an end-to-end project with the machine learning and the machine learning bootcamp. So from notebook to live link, that's that about deploying with a Gradio that I just showed you. And yes, so the link is working. So I hope to see you in the next video. Thank you so much for your time.